Okay, so we're reviewing for a quiz. Quiz is tomorrow. It's on 12.3, 12.4, which is basically Venn diagrams at expected value. So here's the problem I want you to work on right now. I pull a random bill out of my wallet. I have 8 ones, a 10, and a 20. It's the expected value of the bill that you pulled. Got the answer already? Oh, cow, that's fast. Okay. I want you to just take a minute. Do P times A for each thing, and then add them all up. All right. What's the probability of getting a 1? 8 out of 10. Because there were 8 ones in there. There's 1 10 in there, and there's 1 20 in there. Oops. There's 1 in 10 chance of getting 8 ones. Okay. Then what's the amount I get if I get a 1? Well, that's pretty obvious. It's 1. 10, 20, 20. 8 tenths times 1 would be 80 cents. 1/10 times 10 would be $1. And 1/10 times 20 would be $2. Grand total, $3.80. Your expected value. Raise your hand if you knew that. Okay, good. Now, do you get how you shouldn't expect to get the expected value? Because you're never going to pull a bill out of my wallet that's worth $3.80. But if you did it like 100 times and you averaged how much you got, it would approach that $3.80. All right. Well, you do it and then you replace it, and then you do it again, and then you replace it again. All right. So all that being said, reach in, grab something. See what you get. Ooh, it's a 20. Woohoo! All right. Just can't keep it. All right. Moving on. We have to cover, let's see, a bunch of stuff. I got a few problems pre-made here, so I'm going to pause. Okay, here's the first one. So we got rock climbing, snowboarding, and what about those 4.06s? They don't do either one. All right. This is called a probability event. It means there wasn't 47 people that were in the middle there. That was a 47% chance. It means that, like, if they had asked 100 people, then 47 would have been in the middle. All right. Now, let's just talk about this for a second. Most common mistake answer. If I say, what's the probability of picking a rock climber? The kid will say 12. 12%. Why isn't just 12 right? Yes. So these guys are also rock climbers. All right, so you should put those together. Okay, so just be careful of that. That's the number one dumb mistake. All right, next thing that gets more complicated is, what if I say I'm only going to pick from the snowboarders? Then what's the probability I get a rock climber? As soon as I say I'm only going to pick from the snowboarders, I eliminate these guys. They can't pick them or them. And so then my probability is not divided by 1 anymore, because it's not divided by everybody could have been picked. It's always what you want over what's possible. And what I want here is a rock climber, but I can only pick from the snowboarders, so I put these together, and that goes on the bottom. 0.82. There we go. You get how I did that? The bottom is important. You can't just say, oh, I'm just going to take the 47, that's it. Because I said you could only pick from snowboarders. These were the only things that were possible. So they go on the bottom. All right. I'd like you to try to answer this first question. What is the probability that a randomly chosen rock climber is a snowboarder? Just like the one I just said, except this time we can only pick from rock climbers. I don't expect you to actually divide them. You can just leave your answer as a fraction. You know, like 0.47 over 0.12 or whatever you think it is. All right, in the back row, LD. Tell me what you think. 0.47 is what you want because you wanted somebody who is a rock climber. Is that what you're saying? Okay. Out of what? Because you put those together, you got 0.59, and those are things that were possible. So to me, it seems like you were only picking from rock climbers. Yep. Just rock climbers. And you wanted to find a snowboarder. Snowboarders for that one. Very good. Raise your hand if you had that one right. Okay, good. On to the next one. What is the probability that a randomly chosen person, that means you pick from anybody, is a rock climber or snowboarder? All right, let's talk about or for a minute. Or to me seems like one of those numbers that should be like making the answer smaller, but it's actually making the answer bigger. And here's why. If I were to ask you guys, if I was going to pick somebody who had black hair, I'd have a decent chance if I was going to randomly pick somebody. Okay, but if I said, I'm going to pick somebody who has black hair or blonde hair, because my probability just went up. Because I got a lot more people now. Because I could have black or black. Or means your answer gets bigger. All right, so then, rock climber or a snowboarder? This works. So does this, and so does this. I know people think or means like two of them, but not the middle one or something. But or, if you ask this person, are you a rock climber or a snowboarder? They'd say yes. Are you a rock climber or a snowboarder? They'd say yes. And these people, unless they're being really annoying, you said, are you a rock climber or a snowboarder? They should say yes. Okay. And they shouldn't say, no, I'm a rock climber and a snowboarder. That would be kind of just snotty. So anyway, these people count. So you should include them. So or is all of those. Okay? But on the other hand, if we said and, I only win if I find somebody who's a rock snowboarder and a rock climber, then I would ask these people, are you a snowboarder and a rock climber? They'd say, no, rock climber. And these people would say no. These people would say yes. So and is a small answer, or is a bigger answer. So now, would you please answer this one? What's the probability that a randomly chosen person is a rock climber and a snowboarder? That's a pretty simple one, isn't it? What is it? 1/7. All right. Now I'm going to change the question to make it harder. What if I say, given I know they either rock climb or snowboard, then what's the probability that they are a rock climber and a snowboarder? Okay. Given that I know they do one of the two things, they're either a rock climber or a snowboarder. I know they do something. They're so athletic, they just have to do one of those two things. Then what's the probability that they are a rock climber and snowboarder? It doesn't matter how many people it's out of because it's a percent diagram. So it's already calculated that for you. So it's out of 100%. All right, so how about this? Rock climber and a snowboarder, do you get that this 47's got to be 47, right? So it's still 47 on top. But the thing is, I said given. As soon as I say given something, given that they have to be either a rock climber or a snowboarder, then that changes what's possible. Not everybody is possible. You get that? As soon as I said given that they were a rock climber or a snowboarder, these people got thrown out. See what I mean? So I was only picking from this. These are the only things that are possible. So they go on the bottom. So 0.47 divided by 80, 94. Like that? Because I changed the problem by saying I know that they do one of the two. So that ruled out these guys weren't possible. All right, next one. Given the a randomly selected person is not a rock climber, then what is the probability that he or she is not a snowboarder? about as hard as they get. Handle. Trying the last question. That's what I'm going to ask you to billboard to me. So once you're done, yes, I'll move it up a smidge so you can see it better. Okay, there you can see all the numbers. Given a randomly selected person is not a rock climber, then what's the probability he or she is not a snowboarder? Okay, so this is the rock. And this is this one. All right, I want to see. Take your time. Tell me if this. I think this is going to be a divided by something question. You know what I mean? Like, give me your answers like 0.27 divided by 0.94 or whatever. Okay, hold on just a second. Let me make sure I get the right answer. And you're right, and you're right, and you're right. You're close, but your bottom number's wrong. You're right. You're right. Layer issues good. 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 You don't like it anymore? The top numbers must be the top is good. 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 Yep. A couple people haven't participated yet. Yep. Top part's wrong. Bottom part's right. Good. Yep. 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 Okay. I may not have got everybody, but I got close. All right, so let's talk about it real quick. Remember, it's what you want or what's possible. What I want is somebody who is not a snowboarder, but what's possible was they were not a rock climber. I knew they weren't rock climbers, so I had to throw these out right at the beginning. So these are the only ones that are possible. That's why it's out of point number one. And what did I want? I wanted somebody who was not a snowboarder. See? So now I say I don't want these people either. I really want that. That's what I want. These are what's possible. So what I want, 26. 24. Okay? Alright, good enough on that. That's double Venn diagrams. How about triple Venn diagrams? Here's the fat cat. Like he stuck an air hose in that thing and blew it up. So this is a iPad, cat, phone overlapping situation, and the most important number of all is the overlap of all of them. And in this case, they don't give that to me. All right, I want you to just start with me by drawing a triple Venn, like 3 circles that all overlap, and put I and C and P. I for iPhone, C for cat, P for phone. And make sure you do the iPad as the upper left one, the cat is the upper right one, and the phone is the bottom. Now, 51 people were surveyed. I like to put total stump in my Venn diagrams. So the total number of people we asked was 51. I'm going to put that up here. Upper left. You can put it in the upper right. The only place you don't want to for sure put it is lower right, because that's where you put stuff that the people that are left out go down here. People that don't have a phone or a cat or an iPod. Okay. All right. So now, one thing at a time here. I got the 51 taken care of. That's the way I do it. I'd like cross it off once I've done it. Next thing. 26 people have an iPod, and the common mistake is, oh, people just write 26 right there. Because all of these areas add up to 26. So you can't just write in 26 there. 26 is all of those things. So I put the 26 here by where it says iPod. So I know that whole circle adds up to 26. Next thing, 4 people don't have an iPod, cat, or phone. 4 people don't have an iPod, cat, or phone. So the 4 people are there. All right, so I've taken care of both of these now. 12 people have a phone, but not a cat or iPod. Phone is in here, or here, or here, or here. 12 people have a phone and not a cat and not an iPod. So they couldn't be here, they couldn't be here, they couldn't be here. So that number is 12. So down there, 12. Got that one done. Now you see if you can figure it out from the rest of this. Should I zoom in on it a little bit? Is it hard to read or? Yeah. Don't know what's going on.
Are you still alive?
Weird.
Test, 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 test. Test, test.
Man, we got some major feedback going on here.
Test, 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 test.
Weird. Here's a DVD player. So basically that was coming through channel 6. And this happened to happen the moment that I opened the cabinet. That doesn't seem like it. Okay. Some weird stuff going on. That was recording the whole time. It's okay. Okay. So, the 4 people that have an iPod and a cat but not a phone. iPod and cat but not phone. It's got to be right there, right? 3? Okay, good. 6 people have a cat and a phone. Phone, but not an iPod. Cat and phone, but upstairs. 6, there we go. Yep. You're going to have one of these on your test too, so hopefully you're glad you passed. 15 people have a phone and a cat. 15 have a phone and a cat. Oh, so the total of these two is 15. So what's the middle one got? 9. Now you got that, you get a lot of stuff. Because now you can go, okay, for my phone, which one should I do next? Okay, 15 people have a phone and a cat. I better do that first. 15 people have a phone and a cat. Phone and cat overlaps right here. I already got that. Next one, 14 people have an iPod and a phone. 14. iPod phone is right here, and that's a total of 14, and therefore it must be 5 here. And now I can figure out this number because the total has to be 26. And so I go 26, but I've already got 4 and 5 and 9, which makes it 18. So that one. Do you think 8? Raise your hand if you had 8 in there. Okay, good. And the next one I can do is, I know all of the numbers except for this one. So what do they have to all add up to? 51. And then you just add up all the other numbers, and how many are left? How many said 3? Okay, how many said something other than 3? Okay. I'm not. People aren't taking much of a stand here, so I'm going to add them up quick. 16, 22, 31, 36, 40, 48, 49, 50, 51. There we go. That is. If you add a drawing, I understand. There's a lot of numbers there. Okay, there we go. So that's making a triple Venn. And of course, they can always ask you questions about it too. Like they could say, now that we got this done, given that the person has a cat, right away, go like this. Not it. And these are the only things possible. What's the probability they have only a cat? 3 out of all of these added up. 3 out of, make sure you're right, yep, 22. Okay, good enough on that. This one's an expected value. They bought this digital picture frame for $100. Store offers a protection plan for $19.99. Ben knows that 3 in every 200 break. Ooh, that's the probability right there of it breaking. What's the expected value? Find that first, and once you know the expected value is like you're going to lose $20, or maybe it's lose 15 or whatever, then that is also what the store is going to make. Whatever you lose, that's what the store is going to make. Okay, so your expected value, it's kind of like the opposite of the store's expected value. So if you expect to make money, then they're going to have to lose money. If you're expecting to lose some money, then they're going to make that exactly. Okay, so would you please make me a little tree with works and breaks like this, and it's 3 out of 200 break, 3 out of 200, that means 197 out of 200 work. And then your amount you get, P times A, your amount you get if it works is nothing. Go from there. The way I like to do it is I like to save that $19.99 for the very end. Some teachers like to put that you lose $19.99 here. I personally would rather not. I'd say the store is going to give you 0. Nope. If it works, nothing is lost. You haven't lost anything. If it works, you still have your thing that's worth $100. So in the worst scenario, your amount they're going to give you is nothing. 0 times that percent. That's also very easy to multiply. See what I mean? So you're going to multiply 0 times 197 over 200. It's going to be 0. B is a probability. Is that what you're asking? Oh, B. Oh, B. Okay. So B is your probabilities right here. What's your amount you get if it breaks? $100. Yep. So you take P times A, then add them all up. Well, P times A in this case, it comes out to, I think, isn't it $1 something? So P times A, we've done that. Now what are we supposed to do? P times A and then add. So now I add them up. 0 plus $1.50 is $1.50. What are they saying? The value of this warranty is $1.50. Is that what they're going to sell it to you for? No. That's why they want to sell you the warranty at the store. It's so annoying at Best Buy. Every time I want to walk out of that place, they're always like, did you know we have a protection plan for this? It's because they're worth about $1.50 and they want to sell it to me for $20. They want to make a ton of money. Well, usually I say no, but every now and then there's something that I feel like there's a higher than average chance it's going to break. And then I say, yeah, I'll buy it on this. Yes. Yes, they do shop at Best Buy. I do shop at Amazon too, mostly at Amazon, but I sometimes go to Best Buy. Yep. The $100 only happens right there. Okay. All right, so now, if it's worth $1.50, what's my expected value? If I pay $19.99 for it, I take the $1.50 minus the $19.99, and that means I'm going to lose, what, 16, 15, 7, 18.49? My expected value is I'm going to lose 18.49, and guess who's going to get it? The store. The store will make 18.49. So Their expected value is positive 1849. I'm expecting to lose 1849. But remember, you don't expect to get the expected value. Reality is either you're not phone, in this case, your digital picture frame, either it's going to break or it's not going to break. So either you're going to be like, yeah, so glad I bought that insurance, or you're going to be, yeah, I wasted 20 bucks. It's one or the other. You're not going to get 1849. You don't understand what. Okay, it's always P times A and then add them up. Do you get that theme we've been doing? Okay, so what, you get how the probabilities here, right? Okay, so what's this? It's an amount. It's the amount that happens if it breaks. The amount you get is $100 because it broke, and now they're giving you a new one that's worth $100. Okay? That's the amount. It's not obviously it's not the probability. It's got to be the amount. The amount they've given you is $100. Now some places actually do give you cash. I've seen protection plans where they'll be like, I'll give you what you paid for your thing back. So I actually give you $100 cash back if your thing breaks. There are protection plans. All right. This one, it's just it's a tree, and since there's none of those on the test, I want to not waste our time talking about that anymore. If you need more help on making trees and stuff, come in the morning, and I'll be glad to help you with that. We have some people that still want to retake tests. You have to have till Wednesday because I didn't give them back to you till Wednesday. You can have till Wednesday of next week to do retakes. Any morning except the Wednesday. And even on Wednesday morning I can work it out. I just have to put it in testing. Yes. All right. That's the end of the video for today.